Chapter 6, 6.6 is taking a look at, let me get this thing adjusted here. Is taking a look at quadratic equations. And with quadratic equations, they are in the form of x squared plus bx plus c equals 0. Or it's the ones that have ax squared plus bx plus c is equal to 0. The difference between these and the ones that we had been working at previously is that the equation is set equal to 0. So we take it an extra step, and the extra step is to move it from this situation into taking it and solving and finding out what x is actually equal to. So some of our problems that they'll give you start out already being factored for you. And so if they're already factored and it's set equal to 0, that's our key piece in here, is that we do have it equal to 0. And if it's set equal to 0, do not FOIL or multiply. If it's not set equal to 0, then we do need to FOIL it, and then we'll talk about those in a little bit as we work our way through these. But if it's set equal to 0, half of the work is already completed for you because this piece has already been factored. So now what we do is take each section or each binomial and set those binomials equal to 0 and solve for the variable of x. So I'm going to add 7 to both sides. So one of my answers is x equals 7. The other answer, I'm going to add 2 and divide by 3. And that one's going to tell me that my answer now happens to be 2/3, because these 3's of course cancel out and I'm left with 2/3 for my answer. So if it's already worked out for you, then don't end up taking it and doing any foiling. Here's a second example. 5x times x plus 5 is equal to 0. For this one, same situation takes place. Because I take 5x, set it equal to 0, x plus 5 is equal to 0. Divide the first one by 5. Find x is equal to 0, because 0 divided by 5 is of course 0. Minus 5 from the second one, and find that x is equal to a negative 5 for that one. And so we have our two answers to this one as well. So 0 and x equals a negative 5 are the solutions that we have to have for that one. Now, ones that you do need to FOIL, we might as well put one of those right in here at this point, is x plus 1, x minus 1 is equal to 8. This one I need to FOIL because it's not set equal to 0. Notice I have an 8 here. So in order to finish it and to solve it, I need to take this piece and FOIL this out. So x times x is x squared. X times a negative 1 is a negative x. 1 times x is a plus x. Positive 1 times a negative 1 is a negative 1. Combine my middle terms and they disappear or cancel each other out. Then, to finish it, I need to get it set equal to 0. So I'm going to minus 8 from both sides. And I find I have x squared minus 9 equals 0. Once I get it to this point, I'm back to where I was at in the previous sections where I had to factor. So now we need to factor this to find out what my two variables are going, or my two values of x that cause this thing to work are worth what the answer should be. So if I break it apart, I have x and x. I have a negative 9, so in my factoring, perfect squares on each end. So one's a plus, one's a minus, and 9's a perfect square, so I get 3 and 3. Then take each of those pieces and set each equal to 0. And solve it. So I'm going to subtract 3 find x equals a negative 3, add 3, and I find x is equal to 3. And so my two answers that come out of this are x equals a negative 3 and x equals a positive 3. And so that becomes my solution for that problem. And if you were wondering whether it didn't actually work, we can take this and check it, because I can go back to my original problem that I happen to have had, and let's rewrite that on here. So x plus 1, x minus 1 is equal to 8. And if I take my two answers, x could equal 3 or x could equal a negative 3, and plug them in, and let's see if it works. So if I put 3 in here, 3 plus 1, 3 minus 1, is that equal to 8? So 3 plus 1 is 4, 3 minus 1 is 2, and 4 times 2 is 8. And if I plug in the negative 3 plus 1 times a negative 3 minus 1 is equal to 8. So negative 3 plus 1 is negative 2. Negative 3 minus 1 is actually a negative 3 plus a negative 1, or negative 4. And a negative times a negative gives me a positive, and 2 times 2 is 8. And so therefore my solution comes out to be the answer of 8. And so I did it right. So both of those work. So this was the check. Guess I should write that at the top of there so that we know that it does end up working out correctly. Continuing on with these, you can have them where you have x squared plus 5x plus 1 equals 7. Now if this were my problem, I still need to set it equal to 0. So if I do that, I'm going to minus 7 from each side. That gives me x squared plus 5x minus 6 equals 0. Can that be factored? That's the next thing I ask myself. Well, I got a single x squared out in front, so that means it's going to have an x and an x. I have a negative 6 at the tail end, which means I have a minus and a plus, but the plus value is the middle, so that one has to be the larger of my two factors. So what are some factors of a negative 6 that multiply to give me a negative 6 but add to give me a positive 5? And if I give that a little thought, it's going to be a positive 6 and a negative 1 will end up making this work. So I take x minus 1 equals 0, x plus 6 equals 0, set them both equal to 0, solve for them. X equals 1 when I add 1 to both sides. And when I subtract 6 from each side, I get x equals a negative 6. And so therefore, those are my two values that I happen to have. And if I check them, I can plug them back in where x is at up here. And if I come out to be 7, I know I did my math correctly for that problem. So there's some checking stuff that ends up being done in these as well. So you want to watch that and make sure you get your checking done to see if we've got a correct solution in there. Another one, z squared plus 13z plus 40 equals 0. This one's already set equal to 0, so I don't have to move anything over. Single z squared at the beginning, so it's a z and a z. Addition at the tail end and addition in the middle, so both are pluses. And some factors of 40 that add to 13. Well, 40 is 1 times 40, that's not what I need. 2 times 20, that doesn't do it for me. 3 doesn't go in there. 4 goes in there 10. 10 plus 4 is 14. I'm getting close. And then 5 times 8. 5 times 8. 5 times 8, yes. 5 and 8 added together is, of course, 13. So one's 5, one's 8. Set each of these factored pieces equal to 0. And I find that x is equal to a negative 5, or x is equal to a negative 8 for my solution to that one. If they gave you a problem such as this, x squared equals 81, set equal to 0, by subtracting 81 from both sides, and I get x squared minus 81 is equal to 0. Get my screen back there. And so once I get that equal to 0, then what ends up happening is this factors. Perfect squares, or a difference of squares, is what I happen to have. And it's going to be a minus 9 and a plus 9. So x minus 9 equals 0 and x plus 9 equals 0. And my two values for my quadratic. So if I add 9 to both sides on this one, I get x equals a positive 9. Second one, if I subtract 9, I find x is equal to a negative 9. So those two become my solutions for that problem. And if you check it and plug it back in, you would find that those would end up working as well with that one. Now, not all of them have a single x squared term in the front. Some give you values that do not have a single x squared out in front, and so we have to be able to solve those. And this is where you use your segment from 6.3b is what we're going to use to factor with. That process is where you take your first term times your last term. But this isn't set equal to 0, so I first have to do that. So I'm going to minus 8 from each side. So it gives me 15x squared plus x minus 6 is equal to 0. So then what I need to do with this problem is, following my 6.3b method, I'm taking the first term times the last term, and that's going to end up giving me 15 times 6. 6 times 5 is 30. 6 times 1 is 6. Plus 3 is 90. So I have 90x squared. So I need things that multiply to give me 90x squared, but add to give me a single x in the center. This will be a negative 90x squared. And when I look at my factors, since it's a negative, I know one's going to be negative and one's going to be positive. 90, there's a lot of different factors for 90, but only one that gives me that, and that happens to be a positive 10 and a negative 9. And so over here, and x is with both of those. So a negative 9x plus 10x is a positive x. Replace my middle, so 15x squared minus 9x plus 10x minus 6 is equal to 0. Group in my 2's. Now I'm using that 4 kind of factoring where I break stuff apart into 2 different pieces. First piece I can pull out a 3x. Leaves me with 5x minus 3. Second one I can pull out a 2. Leaves me with 5x minus 3. I did my math correctly because those two are identical, and you have to have these two matched. No, you did it right. So 5x minus 3 times 3x plus 2 is equal to 0. Set each piece equal to 0. Move my 3 over, giving me 5x equals 3. Divide by 5. So my first answer is 3/5. Second one, move my 2 over, divide by 3, and I find x is equal to 2/3 as well. So these two become my solution to that problem. So I've got my parts in there that I have worked through and worked with to come up with my answers. So let's see what we can do with a few more of these. Here's another one. 3x squared minus 7x plus 5 is equal to, whoops, to 1 this time, not to 0. Need to move my 1 over. So 3x squared minus 7x plus 4, when I subtract my 1, is what I get. So 3x squared times a positive 4 is a 12x squared, and it's multiplied. But it needs to add to be a negative 7x. To be a positive at the end, or the tail end, needs to be a positive times a positive or a negative times a negative, but because the middle is negative, that tells me both factors need to be negative. And 12 would be 3x and 4x. So a negative 3x and a negative 4x gives me a negative 7. Replace my middle. Group in my 2's. Factor out a 3x out of the first one, leaves me with x minus 1. Factor out a negative 4 out of the other one, leaves me with x minus 1. So I have x minus 1 times 3x minus 4. Set both equal to 0. And so I find out that x is equal to a positive 1, and add 4. Divide by 3. And last of all, find x is also equal to 4/3. So 4/3 becomes my additional problem that I happen to have in there. And so we get combinations of stuff in there. One more. 3x squared. Oh, that was my solving for this one, so I don't need to put that one in there. This one. Y squared plus 9y plus 20 equals 0. Back to a single one. So you have a y and a y, so I'm just factoring using my 6.2 factoring. So 20, give me 9, is a plus 5 and a plus 4. So y plus 5 equals 0. Y plus 4 equals 0. Minus 5. So y is a negative 5 minus 4. Or y is a negative 4. So those two are my final solutions and my final answers to that. One last thing that Hawks puts into this section is it takes things for finding the equation. Finding the equation with two given values. And that means instead of going and finding what we just did, they give you that x is equal to 4 and x is equal to 7 and say what is the equation that this started from. So we're basically working our way from the end result back to the beginning of where we started with our other problems. So in here, we are going to minus 4 from both sides to get it back to equal to 0. Same thing with the 7, minus 7 gives me x minus 7 equals 0. Then what I need to do is, because they're equal to 0, we put the two binomials together and set that equal to 0. If I multiply this piece out or use my FOIL, x times x is x squared. X times a negative 7 is a negative 7x. Negative 4 times x is a negative 4x. Negative 4 times a negative 7 is a plus 28. Combine my middles. Negative 7 and a negative 4 is a negative 11. And what I have found is I've reversed my process and have taken that and moved it right back into an equation that I have worked with before. So if I do another one, the next one would be x equals a negative 5 and x equals 4. Do the exact same process. This time add 5. X plus 5 is equal to 0. Subtract 4. And I find x minus 4 is equal to 0. Put these two binomials together to multiply them. FOIL, x times x is x squared. X times a negative 4 is negative 4x. 5 times x is a plus 5x. 5 times a negative 4 is a negative 20. And combine my middles and end up with x squared plus x minus 20 is equal to 0 for that one. And so we're working our way from an opposite direction to one that we had previously to have worked with. And so we get some ideas in there of what's going on with those. if you have x equals 2/3 and x equals 1/7, these, I've got a little more work to do because I first have to multiply both sides by 3. So I get 3x is equal to 2. Subtract 2 from both sides, so I get 3x minus 2 is equal to 0. Do the same thing over here, times every side by 7, so I have 7x is equal to 1. Move my 1 over, and I have 7x minus 1 is equal to 0. So I get 3x minus 2 times 7x minus 1. And if I FOIL it, 3x times 7x is 21x squared. 3x times a negative 1 is a negative 3x. Negative 2 times 7 is a negative 14x. Negative 2 times a negative 1 is a positive 2. Combine my middles. Negative 3 and a negative 14 is a negative 17x. Plus 2 is equal to 0. And I'm back again to the equation that I would have started out with if I had to solve these and make them work. So again, reversing it. So you come back with what the main piece was that you started with those. So always make sure you watch that so you can get your reverse of what you have taken place happening there. So that takes care of that section. And the next section that we're going to move into happens to be your favorite of all, which is story problems. 6.7 is using applications that are dealing with our quadratic equations. And so if we get into those, we've got some here that we need to take a look at, of course, and figure out whether we can come up with what our solutions would be for those. The very first one, and these again are questions that are taken right out of Hawks, so they're the questions you're going to run across in your homework, so they're not anything new. You're not going to show up somewhere for you. So we need to read this carefully. It says one number is 9 more than another number. So if we stop right at that point, that's giving me my two values. One number is 9 more than another number. So one number is x plus 9. The original number is just plain ordinary x in here because I have my two numbers in that sequence. Then it says, and the sum means, of course, to add. So we want an addition in there of their squares. Ooh, squares. Squares means I need to square each of these pieces. Is, of course, means equals. And so equals 261. So that means I need to take x plus 9 and square it, plus x squared is going to equal 261. So to square it, this section right here, I need to take that and multiply it by itself. So x times x is x squared. X times 9 is a plus 9x. 9 times x is another 9x. 9 times 9 is 81. So I put those two pieces together. 9 and 9 is 18x plus 81. So to replace this, because I FOILed it, is x squared plus 18x plus 81. X squared is a simple part. That's just plain old x squared. Combine like things, x squared plus x squared is 2x squared plus 18x plus 81 equals 261. I'm going to set equal to 0 because it's still a quadratic, so I'm going to minus 261. And when I do that, I am left with 2x squared plus 18x. 1 and 1 is gone. 6 minus 8 is 16 minus 8, which is 180 is what I have left in there. Then what I can do with this whole piece is remove a 2, because every piece in here is divisible by 2. So maybe I grab another sheet of paper here and write it on that other sheet of paper. That'll help us out so we have a little more room in here because it's kind of cramped. So if I remove a 2, Divide everything by 2, I have x squared plus 9x minus 90 is equal to 0. And it seems like we just factored something similar to that in the previous part. So I have an x and an x. A minus, so that means a negative and a positive, and the positive needs to be bigger because of that positive value in the center. And so it's 10. No, it's not 10 and 9, because 10 and 9 would end up giving me 1, so maybe we haven't factored this one yet. So what would my factors be? So I can't use 10 and 9 because that gives me 1. So 90 divided by 3 is 30. That's not what I'm going to need. 90 divided by, oops, divided by, I don't need 2 of them in there either. Delete. 90 divided by 4 is 22.5. I guess I might as well, I don't think I can put my calculator on there because it won't pick it up. 90 divided by 5 is 18. I'm getting a little closer. 90 divided by 6 is 15, and that happens to be what I need. So I need 15, and I need 6, because 15 from 6 is going to give me my 9 in the middle. And so set each of these equal to 0. And find x could be 6 and x could be a negative 15. Well, it does not specify that I can't use a negative in this one. So that would mean that both of these answers would work. So if I go back up here to where I labeled each of these, so x could be 6. 6 plus 9 gives me 15. But if x is a negative 15, then what is x? So a negative 15 plus 9 is a negative 6. So really, in Hawks, it will ask you for all 4 answers. So you have to put all 4 of those in when you work this problem out for that one. Continuing on, if we take a look at the theater here, and what does a theater look like? Well, theaters are, of course, usually rectangular unless they're round. In this case, it's rectangular, and we have rows in our theater. And in each of these rows, we have seats in our theater. And so our theater has that type of a dimension to it. So a theater can seat 364 people. The number of rows is 12 less than the number of seats. So rows is seats minus 12, and seats are seats. So we have S is our seats, but our rows are 12 less than the number of seats that we happen to have. So it's how many seats are there in each row. So I need to figure my rectangle out. So that's going to be S minus 12 times S, or the number of rows times the number of seats, number of rows, I should say, times the number of seats, is going to equal 364. So S times S is S squared. S times a negative 12 is a negative 12S. Move my 364 over, so I have S squared minus 12S minus 364 is equal to 0. Now I got to work and say what factors of this, because I have S and S, but I need factors of this that are going to give me that, so I know I'm going to have a negative and a positive, but the negative piece needs to be bigger. So if I play around with 364 in my calculator and start dividing by 2, that's not going to work. Start dividing by 4, no, that's not going to work. Work my way up, I will find that it's a negative 26 and a positive 14, because a negative 26 take away 14 does end up equaling a negative 12 in there. So set each of these equal to 0. And add 26. I get S equals 26. Subtract 14. I have S equals a negative 14. But I can't use the negative 14 because I can't have negative seats. So I can only use S equals 26 for my final answer to that one. This last problem on this page is pretty tricky. It says a rectangle has an area of 176 meters and a perimeter of 54. What are the dimensions of the rectangle? It looks like, yeah, I don't know whether I can find anything. It looks like I'm missing pieces. But if I draw out a rectangle, I know the area is 176. That means length times width. The perimeter is, of course, the distance around this whole shape, and that's 54. And the perimeter is 54 equals 2L plus 2W for what I have. But I gotta somehow get this thing set so I know what L and W happen to equal. So if I divide this in half, that means takes 54, divide it by 2, gives me 27. So 27 equals L plus W, length plus width. If I solve for L and I minus W, that means 27 minus W is equal to L. So now I've got everything in terms of W's. So my area, which is 176, is equal to W times my length, which is 27 minus W. So I have 176 is equal to 27W minus W squared. Move my 176 over, and I don't like the way this is written, so I'm going to have a negative W squared plus 27W minus 176 is equal to 0. Remove the negative, which means all signs need to change. And if I take that one, I need some more paper in here. So if I work this one out, I'm going to have W squared minus 27W plus 176 is equal to 0. Factor if I can. W and a W, and it's a plus, so it's both are minuses. So what will my two answers be? So if I take 176, and I need to come up with a negative 27, so they add together. $176 divided by and they happen to be 11 and 16 is my two factors, so set each of these equal to 0 and find that W could be 11 or W could be 16, and since both are positives I could use either one. And so if I set this up, so W is 11 here, so if I want length, that's 27 minus 11, so my length could be 16. If I work my length in the second one, it could be 27 minus 16, or it could be 11. So I have all the possible combinations there. 11 and 16, width and length, and I have width being 16 and length being 11. And so that becomes my solution to this one. So it is a little bit drawn out with this one because you didn't have any pieces, but we could find them once we found that length was equal to 27 minus W and the width was W for that one. So working the pieces of that one out. Okay, continuing. The height of a triangle is 4 feet longer than the base. So if this is my triangle, what does all that mean? The height is 4 feet longer, so 4 plus B, and the base being B. The area of the triangle is 48. So area of a triangle is 1/2 the base times the height is our formula. Plug my pieces in, so 48 goes in for area. 1/2 times the base plus the height, which is 4 plus B, ends up being my piece. To get rid of my half, times whole thing by 2, So that gives me 96. These cancel. Base times 4 plus b. It cancels here because there's a multiplication, so I don't have to multiply 2 times b and 2 times the other part because it's a straight multiplication going on. So I have 96 is equal to 4b plus b squared. Move my 96 over, and I find that 0 is equal to b squared plus 4b minus 96. Factor it. 96 factored is 8, negative 8, and a positive 12 will give me my pieces. So b minus 8 equals 0, b plus 12 equals 0. So add 8, b equals 8, minus 12, b equals negative 12. Can't use a negative 12 because my solution ends up being a negative, and I can't have a negative for my length on my triangle. So b is 8, so the base is 8, and the height is 4 plus 8, or 12. So my two answers are 8 and 12. Be extra careful in Hawks because it will list base. Put in your base value where base is at, put your height value where h is at. So be real careful when you read those through because again it ends up being something that's a little bit different. This one is like the very first one that we solved, and so I'm not going to solve that one because we already got one that's similar to it. This next one though is one number is 2 more than another, so that means I have x and I have x plus 2. But this one has the difference between the squares, so that means I need to subtract them. So x squared minus x plus 2 squared is equal to 48. So x squared is x. X plus 2 times x plus 2 is what? X times x is x squared, is a plus x times 2 is 2x. 2 times x is another 2x, and 2 times 2 is 4. So x squared plus 4x plus 4 is what that's equal to. But because it's subtracted, leave it inside of your subtracted values because I have to change the signs on all of it. Negative x squared. This should have been an x squared up there when I squared my x. Plus 4x plus 4 equals 48. X squareds cancel. So this is only a one-parter. So I need to minus 4. And I find 4x is equal to 48 minus 4 is 44. Divide by 4. So x is equal to 11. So the first is 11. The second is 13. So that becomes my two values that I would have with this one. So that's what happens to it. This is another one that is similar to those others that I did. This one, when you set up your values, x is 1, but the second one is 3 less than twice. So 2x minus 3 is what you'd have with this one. Then the sum of their squares, so I'd have x squared plus 2x minus 3 squared is all equal to 585. The toughest part with these Hawks story problems is that you end up having, your story problems end up having quite large values in here. To write in the rest of this, it's x squared plus 4x squared minus 12x plus 9 equals 585. Combine my x squareds, I get 5x squared minus 12x plus 9 equals 585. Subtract 585, and I get 5x squared minus 12x minus 576 is equal to 0. when this piece gets factored, we can't just factor our pieces out of there. So you've got some extra work in order to do this one to see what you come up with for your answers for it. So I'm going to leave that for you guys to do. Your two answers that do come out of this are that x is equal to 12, and the other one is that x is equal to 21. So we do come up with two values. Remember positive when you factor it, so that you know that you get your answer in there for that one. So again, that's that one. Two consecutive positive integers. So that means I have x and x plus 1. Positive meaning I only want positive values to come out of this one when I work it out. And it says their sum, so I'm doing the exact same thing as I did up above. And again, you square this piece, and we get x squared plus x plus another x plus 1, because x times 1 is x, and 1 times x is x, and 1 times 1 is 1. So I have 2x squared plus 2x, and move my 365 over, gives me a minus 364. Divide every piece by 2, and I get x squared plus x minus 182. And so then I factor this, get x and an x, going to be a minus and a plus, and the plus needs to be bigger. And if you work this one out, you find out it's 13 and 14. So x minus 13 is 0, and x plus 14 is 0. So x equals 13, and x equals a negative 14. And that becomes my two values that I would have for this one. And because it's got to be positive, I can't use the negative 14. So x is 13, and x plus 1, or the next positive consecutive integer, is 14. So that becomes my two values. This last one, I think we need a little bit more paper to work on this one with, is 3 consecutive even integers such that the product of the first and the second is 86 more than the third. Oh, okay. So 3 consecutive even. So x plus 2, and x plus 4. And if you're hung up on this part, give yourself some examples. So an example might be 24, 26, and 28. How do I get from 24 to 26? I added 2. How do I get from 24 to 28? I added 4. So that's my 3 consecutive integers. Such that the product of the first, so x times the second, is, meaning equals, 86 more than the third. So 86 plus x plus 4. So x times x is x squared. X times 2 is plus 2x. 86 plus 4 is 90 plus x. Subtract an x. Subtract 90. And I find that I have x squared plus x minus 90 is equal to 0, because I need it in a quadratic. Factor it. This is the one we factored before. So I have 10 over here and 9 over there. So x equals, or x minus 9 equals 0, and x plus 10 equals 0. So I add 9, get x equals 9. Subtract 10, I find x is equal to a negative 10. And it says consecutive even integers, so that means good old 9 I cannot use, so I can only use a negative 10. So x is a negative 10. The second one is negative 10 plus 2, or negative 8. And the last one is negative 10 plus 4, or negative 6. So those become my main problems that I have there. Okay, so that's what I end up having for that one. Okay, then finally, the very last problem. And the very last problem is, and I think I got plenty of paper on there to use, so I don't need my scratch, is looking at Pythagorean theorem basic formula that I have. And with this one, or we can basically use probably well, we can't use a triangle because we don't have area. So this is my bushy tree over here. And it says a support wire is 10 meters long, is stretched from the tree to a point on the ground. So this is 10 feet, or 10 meters. And then it says the point of the attachment on the tree is 2 meters higher than the distance from the base of the tree to the point on the ground. So if this is x, this on the other side is x plus 2, because it's 2 meters higher with that one. Now the Pythagorean theorem is a leg squared plus a leg squared is equal to the hypotenuse squared. And legs create your right triangle. So my legs in here, this leg and this leg, so that means I need to take x plus 2 squared plus x squared is equal to 10 squared. So I have my hypotenuse in there that is squared. So if I square this first piece, I end up with x squared plus 2x plus 2x plus 4. Square the second one is x squared, square my 10, I get a good old 100. Combine like things, I have 2x squared, I have plus 4x plus 4 is equal to 100. Subtract 100 and get 2x squared plus 4x minus 96 is equal to 0. Once again, pull out a 2. 2 goes into 9, 4, 2 goes into there 8 times. See if I can factor this. It's going to negative and a positive, but the positive needs to be bigger, and 48 is 8 and 6. Set each equal to 0. Add 6. So I find x is equal to 6, subtract 8. X is equal to negative 8. I can't use a negative 8 because I'm looking at distance. So 6 is what I use, and it says how far is the point of attachment. So if we look at these, this side is x plus 2 or 6 plus 2. This is up 8 meters. This is at 6 meters. And so the point of attachment is 6 meters out. So my answer to this would be simply 6 meters. And so that takes care of all of the section of 6.7.